Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day. My name is Muhammad Shukillah bin Razali, and today I'm going to present the lab report on Bernoulli's principles, which is under fluid dynamics. So the lab report will be consist of introduction, objective and methodology, results and discussion, and finally conclusion. Moving on to the first part, which is introduction. The first question is, what is Bernoulli's principle? The Bernoulli statement states, for an inviscid flow, increase in speed of the fluid occurs simultaneously with a decrease in pressure, which means the speed of moving fluid increase, the pressure will decrease. Next, we look at the flow rate of fluid, which is given by this formula, which means the smaller cross-sectional area results in higher velocity. And one of the application is Venturi effect. Look at this picture here. Venturi effect is the reduction in fluid pressure that results when incompressible fluids flow through a constricted section or choke of a pipe. So, the objective of the experiment are to investigate the relationship between velocity and pressure in an incompressible fluid, and second, to verify the Bernoulli's principle. Moving on to the methodology part, the experiment was set up as shown in this figure here, which consists of water tank, water tap, venturi tube, clip, and also the sink here. Firstly, the water tap is open to allow the water flow to the venturi tube until all the section have the head of water half from the tube. And second, the clip is open to allow water to flow into the sink. And we need to adjust the water tap here and also the clip here until the water level in the tubes are all stable. And finally, we observe the water level in each tube. Moving on to the next part, which is results and discussion. To have a better understanding, you may have taken note on this part. Let me explain. At A, here, it says that it has the highest pressure. Why? Because at A, it has biggest diameter of tube. Hence, it provides the lowest velocity because Q is equal to VA. Hence, the lower the diameter, lower area, which means the highest velocity. Therefore, it has the highest pressure at A. At B, it is smaller diameter, is the smallest of diameter of tube. Hence, it has the highest velocity. Therefore, it is the lowest pressure at B here. At C, it has the same diameter with A, but we need to remember a fluid will flow from high pressure to lower pressure. Thus, the pressure at C here is lower than A but higher than B because of at C it has a higher diameter than B, which results in lower velocity at C compared to B. So, to conclude, to simplify this, we have to look at this point, which means the velocity at A is the lowest, the velocity at B is the highest. The pressure at A is highest, the pressure at B is the highest. No, the pressure at B is the lowest. That's it. Finally, we move on to the conclusion part, which consists of 3 points to conclude our experiment. First, the Bernoulli's principle is verified, which means throughout the experiment, we follow the Bernoulli's principle. Second, we know that the pressure is inversely proportional to velocity, which means the higher the velocity, the lower the pressure. And finally, the velocity of incompressible fluid highly depends on the cross-sectional area of a tube, which means the lower the cross-sectional area will result in the higher velocity. That's it to conclude my presentation of the lab report. So, thank you. See you again.